angle bisectors, what they do in triangles. So I think the easiest thing to start out with is to just take a second and actually draw a segment, and then why don't we kind of guesstimate where the midpoint is? Here-ish, right? So we're going to talk about what's called a perpendicular bisector. In years past, we used to do perpendicular bisectors okay. In years past, thank you. Did you have your name on it? No. Oh, you found it. Thank you. No problem. So in years past, we used to do this as a progression. We're not doing that anymore. It's not a big deal. So you don't have to worry about progression stuff for any of this right there. What we're looking at here. What I want to do though is talk about the definition of what's called a perpendicular bisector. Well, when you see the word perpendicular bisector, that means there are two things that happen. One thing that happens is that you get perpendicular. When two things are, when you have a perpendicular bisector, obviously you're going to get right angles. That's what you get when you have perpendicular. We all know that. That's not a big deal. But we also know that if it's a perpendicular bisector, it also bisects a segment. Hence the term perpendicular bisector. So it does two things. Now, here's what I want you guys to do. If you have a picture like this somewhere on your notes here, I want you just to put a dot anywhere on the perpendicular bisector. Anyway, no matter where. And now what I want you to do is just draw the endpoints of the segment. Does everybody see that there are two right triangles here? Okay. Do you agree that this segment here is reflexive? Are those two triangles congruent? Because of what? Side angle side, good. Side angle side, okay? They're congruent because of side angle side. Now, when you have triangles that are congruent, what can you say then about all of their corresponding parts? They're also congruent. So, with these two guys here, side, angle, side, side, angle, side, we get the two triangles being congruent. Okay? Now, that means then these two guys have to be congruent, right? Why? Yeah, because that old CPCTC. Okay. Now, what happens if I change this dot and put it up here then, and redraw those? Wow. What do I know about those legs? Those two sides. It's still going to be congruent, aren't they? Because all it's changed is the reflexive side just changed. The reflexive side is still reflexive, isn't it? That doesn't change. What if I put it up even further? Are they still the same? What if I put it really close? Still the same. Because no matter what, you always have the right angle, and you always have that reflexive part going up and down. It doesn't matter where it winds up. Because you know that those two segments on the segment to begin with are also congruent. So what this gets us to is this idea that if you are on the perpendicular bisector, that's this part here. If you're on the perpendicular bisector, you are equidistant to the endpoints of the segment. I'll show you. Equidistant. Equidistant. Instead of writing the word equidistant, I just wrote equal dist. No matter what, you're always going to be equal distance to the endpoints in the segment. Basically, another way of looking at this is that perpendicular bisectors, they always make isosceles triangles. If you think about it, when you have a perpendicular bisector, no matter what you do, that's always going to happen. Reflexive, bisector parts, right angles. That means these have to be congruent, which means these base angles will be the same, so on and so on. The perpendicular bisector, if you draw the sides out of it, always make an isosceles. It's a really easy thing to work with. Not terrible. A lot of words for basically something that happens when we get into some very, very, simple algebra. For example, again, a lot of the stuff we're going to do over the course of this chapter, it's quick definitions like this that are going to allow us to set up some very simple algebra. If you look at that diagram, do you have a perpendicular bisector? And why do you know that? Yep. Everybody see that? That means that segment BD is the perpendicular bisector of the segment AC, which therefore means the sides that it draws out from have to be what? Again, it's using a very, very easy definition to do some algebra. So algebraically, what do I have to do here? Go ahead and say it. Go ahead and say it. Yeah. They have to. Remember, this is the perpendicular bisector, which makes this reflexive. You've got two triangles that are congruent, which means CP, CTC. You get that. This style here of the algebra is one of the ones that you guys tend to not like. Because if you move that 4x right away, what do you get on the other side? A 0. Don't forget that. Okay? Don't forget that. So if you move 4x, you have 0 equals 2x minus 10. And then you add your 10. That's fine. You can do that. Okay. There's multiple ways of doing it, but I know for a fact of doing this for maybe once or twice. I know where you guys screw up, and that's usually where you guys screw up. Because then you just got to know it's negative. You have negative 2x, negative 10, divide that, so you get positive 5. Perfectly fine. There's more than one way to do this. Should get the right answer. And then if it says figure out what AB is, well, what do you do with that 5? Okay, what's 4 times 5? All right, check it. So check it, make sure the other side's also 20. What's 6 times 5? I know I'm asking a lot. Subtract 10, you get it. Correct. Pues español es muy bueno. What? 50, 60, 60, 80, 90, been a couple of years. Okay, try again. It's been a few years. Oh no, what do you do to figure out what that is? Because I was making sure you weren't worried. Good, I'm glad. You're welcome. Again, it's once you start understanding the idea that this, if you're on the perpendicular bisector, you're basically creating an isosceles. That's the easiest way to remember how this stuff works. So you just set them equal to each other. Are you guys okay if I do it all in one step? Subtract 3n, add 7, coming back. Over time, we'll start skipping some of our steps. I got 3. Good. So now I have to figure out what PQ is. Be careful. 3 times 3. 9. Okay, subtract 1. 8. Check it on the other side. Make sure you didn't dumb goof. 5 times 3. Subtract 7 and you get. So we did not dumb goof. Okay. Well, that was tough. What's an angle bisector do? Bisects an angle. Pretty immediate. Now, to think back to when we did angle bisectors, when we did proofs, what was the thing? I mean, I know you don't have the progression in front of you, but you probably know what you can say. If you had an angle bisector, what would you guys say? You're right, but what would you be able to state before you use the definition? What happens when you bisect an angle? You get 2 congruent angles, okay? So let's see how well I can draw this. Probably not. Yeah, it's close. Yeah, I can't draw this. That's better. So, if you have an angle bisector, we know that it cuts the angle into 2 congruent parts. Are we okay with that? All right. Now, let's do this. Pick any point on the angle bisector and just put a dot. Again, I'm just going to do this. Now, how many of you guys ever used a tape measure? I have. I hope most of you guys have used a tape measure sometime in your life. If you had to measure something with a tape measure, if I got to go figure out from how far it is from here to the wall, am I going to measure to that corner of the wall or so it's straight at where it's perpendicular, correct? Because isn't that the shortest distance between 2 points is always the perpendicular distance? It is. Say yes. Okay. Because as much as I'd love to go visit that corner over there, it just could take too long to measure. But if I got it here, I'd be there quicker. So try and draw to the sides of the angle what looks like would be perpendicular. So you get something like that. Do you agree that you have 2 triangles there? I do. Are they congruent? By what? You're about to say there's a reflexive. Good. So I agree there's a reflexive here. What is it? Angle, angle, side. Again, what I'm trying to show you guys is that you get angle, angle, side. Angle, angle, side. Angle, angle, side. So these 2 triangles are congruent to each other because of that reflexive. No matter where I put this dot on here, I can still draw perpendicular to the sides and I'll still get angle, angle, side, no matter what. Just like we did with the perpendicular bisector. It doesn't matter where you are on it, you're always going to be equidistant to those endpoints with the perpendicular bisector. Here it's the same deal. Whenever you're on the angle bisector, you're equidistant and perpendicular to the sides. If you are perpendicular to side. And 2, you are equidistant. Two sides. Okay. Because you can show that the triangles are congruent because of angle, side. Don't worry, you're not doing any proofs in any of this. Okay? All we're worried about is how do you, well, a lot of things we'll say prove that you're on the angle bisector, but we're going to prove that we are on it because of the algorithm. What's wrong? No, what's wrong? I don't know if you can read my handwriting or you can't see it. What's up? Here? Like, there's two things. One, you're perpendicular to the sides. Two, you're equidistant to the sides. I'm just labeling the two things that it happens. That's all I did. So, guess what that means we're going to do algebraically? A lot of the same stuff we just did. Setting things equal to each other. I know. Take a second and draw this, and I want to explain to you some of the things you should look for in order to be able to do one of these types of problems. Because there's a couple of things like, I don't want to say like a checklist, but there's a few things you always want to make sure is happening before you can do the problems like we would normally. I didn't hear you. There's that. Why, where are you going? For what? What kind? Why are you going? You're gonna say? So, you think it's about music? Possibly it's about songs. I don't think it's about that. I'm gonna go ahead and say that. There's not very good rap songs.
Oh, actually, there are female songs.
Maybe if we have time, I'll show you. Anyway, like I was saying, in order to be able to do a lot of these problems, you first have to be able to tell if they're on an angle bisector or if they're on a perpendicular bisector. In this case, obviously we're working with an angle, so we have to check to see if it's an angle bisector. If you're on an angle bisector, you're perpendicular and you are equidistant to the sides. From here, it's just showing that we are equal, or excuse me, that we're perpendicular. But look at the big angle of N, M and E. Has that been bisected? No. Why do you say it has? And more specifically, though.
I'm talking about the two angles.
No, I'm talking about. Yeah, I'm getting here. And if you can't see it. Work.
Oh, wow.
Shut up. Do you see it okay? I can keep zooming in. Those tick marks mean what? You can't see it? Are you sure I can try and zoom in a little bit more? Anyway, this is okay. what's on an angle bisector? Which means, what do you have to do algebraically? 70? Okay. So, what do you write? Pretty crazy, isn't it? Gotcha. Okay. So let's check it again. 7 times 5. 35. Okay. 2 times 5. All right. 2 times 5 is how much? You don't want to say, you don't want to be wrong, do you? What?
Yeah, 35.
Sorry, I almost went into a Pulp Fiction reference, and I probably shouldn't say those things in school, so it's okay. No. Say what again? Are you kidding me? Seriously? Pulp Fiction? Seriously?
We should watch it this time.
No. I really like my job. Really?
I'll go watch it live.
Yeah, can't be. Like you ever heard the term a spaghetti western? A spaghetti western is like a bunch of different stories that turn into one big story. Yeah. Watch it. It's one of my all-time favorite movies. It's really fun. It's a good movie. Might be. Anyway, again, when we start. I don't know. It's like shiny. So as you go through ones like this, again, it's just a matter of identifying if something is actually on a bisector or the angle bisector, excuse me, for this one, and then just set up the algebra. As you can see, the math of this is really pretty quick. What becomes a little bit more time-consuming is just kind of making sure you're not doing something stupid, and that would never, ever, ever occur. Ever. Yeah, right. So algebraically again, we get 6x you get 3, but just like we've been saying all along in geometry, it's not just solve for x, it's solve for x and do something with it. Substitute back in, so we're trying to figure out df. 4 times 3 is, add 9 and you get 21. Good. Now make sure you didn't screw it up, so what's 6 times 3? Add 3, you get? Yay. Okay. Where's that? There's a couple other definitions that we need to get into. We just need to get to in second hour. So,
Oh, yeah.
All right, real quick. As of right now, as of right now, on both sides, the bottom problems on both sides, the two on here, number 13 and 14 says, is talking about things called an in-center. You don't know what that is yet, so skip it. The other one on the other side here, the 13 through 18 diagram, on the other side, it also talks about where these specific points of where the perpendicular bisectors meet. We haven't discussed that yet. We're going to talk about what's called points of concurrency tomorrow. It's really simple. It's just we ran short in second hour, which means there's no reason for me to get ahead in a different class. Right? So you guys want a little bit extra time. Now, one of the things I want you guys to recognize here is if you are looking on where the angle bisector side is, I think that's the one that says 5.3. The other side I think says 5.2. It's kind of a mixture. I'm using some of the older textbook sheets on this one because the new textbook basically did proofs in this chapter. We're not doing any, so we're kind of going algebra here. So if you look at number 4, it's asking you, can you conclude if segment or ray BD bisects angle ABC? And what that means is they're trying to see, is there enough information to say, is that a true or false statement? Yes or no, and why? Well, what I would do, if I'm looking at this problem, is that I have to remember that in order to be on the angle bisector, I have to be perpendicular and equidistant to the sides. What does this one say? What's the only thing given to us in the diagram here? The right angle. Does it say anything about the side lengths? Does it say anything about AD or DC saying those are the same? Does it say that angle, the big angle B, has been bisected at all? So is there any way that I can say for certain that this is a bisector? No. There's not enough information here. Okay? You could have right angles, but remember, I could also draw here I'm going. Obviously, this I tried to draw it out so it's a little bit more skewed to one direction, whereas in this case, they're trying to make it look like it does work, but it doesn't have enough information. There's not enough information here to say that it works. We'd have to have these guys set up. I'd have to have at least that angle shown, because if that angle is shown, then I could have done reflexive and gotten angle side, and then it would have worked. But since I don't have that, let me go back to look at that picture here. It just says that they're equidistant. Does it say they're perpendicular? There you go. All right, so it's a little bit like that one. What's that? No, not enough information. They're not shown perpendicular. Now, no, because there's nothing else that tells you that it would work. Okay, but if you remember, I just drew this picture here. No, I know. That's fine. Yep, this is perfectly fine, but that doesn't get you anywhere else, though, does it? Even if you have reflexive, I still have reflexive here, don't I? But do I have any other information? No. There's only two angles. There's no other set of sides or angles that'll make it work. So, like we were saying, is that you'd have to have those two shown, or you had to show that something else was happening. That's why it doesn't work. Also, go back to the other side real quick. Just a little hint. This is another one of those big picture problems. It says that EH is the perpendicular bisector. So if that's the perpendicular bisector, that means that these two guys have to be the same. That means that these two guys have to be the same. And going from there. You notice that you have a 3x plus 4y for one section. You're going to ask me a question here in a minute. You have to be able to solve for x and y separately before you can do the 3x plus 4y part. So we'll get to that. Okay? Other than that, this should not take very long. This is really quick. Okay? Maybe, I don't know. We're not dealing with any angles, there's no 180s. That helps.